over
Yeah.
2 root 3x plus 4.
Yeah, very good. Awesome. Awesome. All right. So now there is somewhere, and this is the hard part, but because it's multiple choice, you don't necessarily need to solve it. You can use one of those test taking strategies. You can either try some answers or you can solve this equation. What do you think would be best? What would you end up doing?
I'm not sure.
Okay.
Would
Well, then you can go back to kind of the old, like, okay, I'm going to diagonally multiply. 6 equals 2 square root 3x plus 4 and solve for x.
so wait, where'd you get the 6 and 6 from?
Multiplying 3 times 2 diagonally. I guess my cursor's not showing up still.
Oh,
3 times 2 diagonally.
okay. Wait. Oh, okay. So wait, so should I solve that out right now?
Sure. Or you got to try the answers. Yeah,
So
one
how
or
would you
the other.
try the answers?
You'd put the answers in for x, and one of them
Oh,
would turn this into 1/2.
wait, I'm trying that out. I got 5/3.
5/3, good. All right. As you can see, that took kind of a lot of time, for this. I mean, it comes down to how fast can you take your derivatives, solve your algebra. It's just a lot of, computation. So, all right. Notice they're giving you the derivative in this. And when they're giving you the derivative, figure out where it's increasing and decreasing. You make a sign chart. So
Wait,
first question.
what'd you what'd you ask?
Well, I'm not asking anything yet. I'm just sort of talking out loud about, they're already giving you the derivative. So
So if it's asking for when it's increasing, that means when f prime of x is positive.
that's right. So you have to first determine critical points, which in this case is where the derivative equals 0.
So
That's where the numerator equals 0. Where does x squared and x plus 1 equal 0?
okay. So x equals 0 and -1.
The second thing you need is where the derivative is undefined. So where you are dividing
1.
by 0 at 1. Okay, and then you have the test points in each region and decide
Yeah.
whether it's positive or negative. So there's a few answers that it can't be. Like it can't be A, because A um, doesn't, it's 0, it's neither increasing nor decreasing. Although I should be careful here. I mean, it's maybe an old question, but I would exclude A. Um, but having said that, you're just looking at the sign. So like, let me pick a number like -1/2. Okay.
Mm-hmm.
-1/2 squared is positive. -1/2 plus 1 is positive. -3/2, the cube root keeps the sign. So that's negative. So you have a positive times a positive over a negative is
A negative.
negative. So go ahead and see if you can figure out the
Would
rest of these.
0 to 1 also be negative?
I mean,
If you
Is
plug in
it, did
one
you,
half, positive one
yeah,
half.
yeah, I mean, did you, yeah, you gotta just try it. I mean, you can't assume, but yeah, it is negative.
Mm. For one, like, because if you plug in like two, it's also positive. So after one, it's positive.
Okay, so there's an interval there. How about like -2?
Positive.
It is positive. So
What?
that is how you figure this out. So
So
what would the answer be?
B.
It is B. Good.
Okay.
All right. Next question we'll look at is 5. All right. So there's a couple of ways to do 5. Um, if you remember indeterminate form of this, if you put infinity in for x, you get indeterminate form. Do you remember L'Hopital's rule?
Um, you find the derivative, the top and bottom.
Yes, separately. So it's not a quotient. So go ahead and take the derivative of the top for us, and then the bottom. That is one way to do it. That may not be the best way, but that is one way to do it.
So wait, would you? So if you find the derivative of top and bottom,
What's
what
the
do you
derivative of the
call-
top? Start with that.
so x squared minus 14. 1 over, no, wait, it'd be 2x over
Right, right,
2 square root.
right. So it reduces to this. And what's the derivative of this next thing? What's the derivative of 3 minus 2x?
Um, and then the bottom is just -2.
Right, so you can put that back here. You still take the limit as x goes to infinity. So you got x over -2 square root x squared minus 14. We kind of got the same issue here, though. They both go to infinity again. So that is one possible way of doing this. If you take yet another derivative, you get derivative of the top is 1. On the bottom, you get the -2 times the 2x over the 2 square root x squared minus 14 like that. And you'll see you end up getting, after you manipulate this, you end up getting back to x squared minus 14 over minus 2x. You're basically back to what you started with. So
Mhm.
this doesn't really work. It doesn't really help you. But there are other options. So the more the more common option is to divide the top and the bottom by the highest degree exponent, which you might think is x squared, but since it's under a square root, it's really just x. Okay, and then in the numerator, this becomes x squared minus 14 over x squared, all in the root, and on the bottom here it's 3 over x minus 2. So this part up here in the top right becomes, we'll come down here, becomes the square root of x squared over x squared, 14 over x squared, which becomes square root of 1 minus 14 over x squared. And then you're dividing that by 3 over x minus 2. So now when you take the limit, when x goes to infinity, what happens to 14 over x squared when that goes to infinity?
It goes to 0.
So the top becomes just the square root of 1. And the bottom, what happens to 3 over x when x goes to infinity?
Um,
Goes to 0.
yeah.
So that's negative 1/2. All right. Any questions on that?
Yeah, that makes sense.
Okay. Next question here. Next question here is giving you the second derivative. Okay. Um, so let's look for concave up. What do you remember about concave up and the second derivative?
Wait, you said when is a concave up?
Yeah, for the second derivative, what does that like what are you looking for?
Like, what's it called?
Like first derivative tells you where it's increasing or decreasing.
Like, what's it called? 0 to 2?
Okay, so where it's positive basically. So we got -2, we got 0, we got 2. Those are the places where it equals 0. So it's concave, down, up, up, and down. Does that make sense?
Yeah.
Okay. So um, the concave up is where the second derivative is positive. Now, increasing, the original function is increasing. So it's increasing when its first derivative is positive. Okay. But we're not able to look at the first derivative, we're able to look at the second. So how do we tell from this graph if the derivative was positive or not, first derivative?
The slope is positive.
Yeah. So uh, how does that affect your answer here? Like we're basically down to those two.
So, like, -2 to -1 and 0 to 1. Or wait, what are you asking for me to
Well,
do?
you answered already. Where is the slope positive? It's positive there, there.
Yeah. But what does that have to do with the number line?
Uh, nothing
Or
on
the
here.
first number line?
Nothing on here. It's just you have to know the rules for one versus the other.
Mm.
All right, so we can move on to another question. It's a B there. These are all pretty complicated. They're all sort of they require you to know a bunch of stuff. You can't just sort of like guess at what they could be. Um, all right. God, these look like they're written a million years ago. So
Wait, what answer choice was that?
I think I put down B here.
G. Okay.
All right, so go ahead and find the first derivative, set it equal to 0, and tell me what you come up with, please.
Wait, when the critical points or the inflection?
Will extrema only occur at critical points
So
on a
that
continuous
inflection point
function?
makes you do double derivative. You do second derivative.
Okay. Well, you will be doing the second derivative. Usually you do the first before the second.
So 60x to the fourth minus 20x cubed.
Okay, set that equal to 0 and solve for x, please.
X equals 1/3.
Is there any others?
0.
Yes. So there's a critical points at 0 and 1/3. They are possible extrema. Now you've got to take the second derivative and set it equal to 0.
So 240x cubed minus 60x squared.
Okay, set that equal to 0.
X equals 1/4 and 0.
All right. So,
So 2.
well, how many are the same? And how many are actually inflection points? So you have to be really careful here. You really have to evaluate the second derivative and make sure that it's actually a critical point. These are just possible critical points, or I'm sorry, inflection points. You have to make sure that the sign changes there. So you really want to test the points in the second derivative. Like you said, it's 240 x cubed minus 60x squared. So you really want to know the sign here of this. Now, it helps to know what the graph looks like. There's actually a double root, so you actually know that the graph comes up and touches of this, like it comes up and so it ends up that this is negative, negative, and positive. So this is the only inflection point.
Okay.
Because it's got to switch signs. So then it's like, well, is this one of the is it even one of the critical points? And it's like no. So
So it's only one. So
yeah, well, no, there's none because the none of the this inflection point is not an extrema.
oh,
So I mean I would go with none. Okay. Um, we'll just move on to another question here. I guess all the rest are these longer problems. Maybe not. These are hard to read. I don't know. Let's do this graphing one, this 10. Okay. Given the following conditions, well, which graph best illustrates f of x? So the domain of the function is all real numbers, but x equals 1. So, Aaron, do you have these pages up in front of you? Are they printed or are they scanned? Like I was hoping it's gonna be hard for me to snip in all the graphs. That's why I'm asking. I don't know if you can, and I was gonna ask if you
I
could
can't
eliminate any of them.
access it right now. So maybe we could just do
Okay.
another question.
No, I'll grab the graphs. I just So do any of these graphs have this behavior where it's they're all real numbers except for a -1 or a +1?
Okay, wait.
Or do any of them?
Wait, can you go back to the problem?
Yes.
Um,
They all have they're all undefined in one, so that doesn't really help us. So that's basically useless. They all have that. Now, the next one here says the limit as x goes to -infinity. So as you go to the left forever is -1. Which of these graphs, when you go to the left forever, approach -1?
um, C,
So C does. Do any of
A
them
does
not?
too.
Okay, yeah. So we can get rid of a few of them. So D is out, and actually B is out, and E is out. Okay. So the next thing here says, as you go to one from the left, it goes to infinity.
So it's C.
It is C. All right. Good job on that. Let's see what else we got. Do you have a calculator available to you today?
No.
Okay. Do you normally have one that you can get access to?
Normally I do, but not with me right now.
Okay. All right. Well, that limits us to not those questions. Let's go back. We're trying to find some more that we can do here. Some of these are hard to snip in because they require a lot of things. Okay, we'll just go back to the beginning. All right, number one. All right, let M represent the absolute maximum of f of x in an interval. Let R represent a root of f of x in the given interval. Let little m represent the absolute minimum of f of x in the interval. If f of x equals x cubed minus 3x squared, which of the following is true over the closed interval -3 less than x less than 1? So we're going to do this a little differently. I want you to find f of -3 and then f of 1 for us, please.
Wait. So you want me to solve that out?
Yeah, yeah.
So f of -3 is -49.
Okay. The other one.
-2.
All right, let me just double check the first there. -27. Uh, -27. I get a different result for the first one here.
Um,
I get -27, -27.
Oh, sorry, I just solved it out wrong.
Okay. The next thing here is I'd like you to take a derivative of this. Give me the derivative.
Okay, the derivative is 3x squared minus 6x.
Okay, go ahead and set that equal to 0 and solve for any critical points.
Wait, sorry, 1 second. Make it equal to 0. Square root 2 plus or
Uh,
minus.
so you can factor out 3x from both. That will simplify it a little bit.
Yeah.
So not
Oh,
no to
wait.
square root of 2.
Oh, so what did I do? Okay, so x equals 2 and 0.
Okay, now are either of these in the interval from -3 to 1?
What'd you say?
Are either of those in the interval from -3 to 1?
No.
I think 0 is. 0 is okay. 2 is not. So we want to evaluate the original function at 0. What does that become?
Wait. What is it? Wait, let me think. What would the answer be? Would it be C or B?
Right. We're not forget about that. Just evaluate the function. That leads. This is I mean, if you don't want to do it this way, you're gonna really struggle to answer it.
Oh, okay.
What is what is what is the
0.
evaluation of 0 in the function?
0.
0. So, which is the max? Which is the min?
Sorry, can you repeat that?
Which is the max and which is the min?
Max is f of 0 and min is 1 or -3.
Yeah. Yeah, there you go. Okay. What do you think the issue is with the audio? Is it not coming through clearly?
I
What
think it's
could you give
on
me some?
my I think it's on my end.
Okay.
Um,
All right. So now the reason we did all that is to go back and be able to answer this question. So let M represent the absolute maximum of f of x in the interval. There is M. This is M. Okay. R
mhm.
represent the root of f of x in the given interval. So we didn't find we didn't actually find the roots, but we can find that. Let little m represent the absolute minimum. So that's little m up here.
So wait, what would R be?
Well, you have to set the original function equal to 0. So
Why
you can
would
factor out an x squared from both,
so
and you
x
get
equals
one at
0?
0 or 3, but 3 is not in the interval. So 0 is also R.
Oh, so M and R
So M and R are the same. Now, little
Would it
m,
be E?
so M and R occur at an endpoint. So is that an endpoint?
Oh, wait, no.
So that one's out.
So lowercase m occurs at an endpoint at though.
That's right.
So A.
It does appear to be A, yeah.
Okay.
All right, good job on that. Let's go to, so I was trying to avoid these symbolic problems. They're just more challenging. But we're kind of running out of stuff. So okay, number 7. Um, and you don't have this in front of you, you said? You can't
No.
access it?
No.
Okay. I'm only asking again because it's like, it's just so frustrating. Like my screen is small. It doesn't really give you the full view here of this. So they're giving you the graph of the second derivative here. So they're giving you the second derivative.
So the graph is G prime double
G
prime.
double prime, yeah. And that's why I like I would recommend going to a sign chart,
Mm-hmm.
um, and looking for those places where it's 0. So an inflection of point occurs when the second derivative switches signs.
When the second derivative switches signs.
Yeah, the graph switches
So
signs.
just 5 though.
Yes, just 5. So so that would be the answer to that one. What about 7? So what I recommend is
Oh
putting
yeah.
the signs in the chart. That way you can see any changes from minus to plus or plus to minus.
So yeah, just 5 and 7.
Yes. So how many are there?
2.
2. Okay. I think the next question kind of refers to this as well. Or maybe it's just that's the way it, uh, oh no, it's the same question. All right. Okay, on to number 9. Number 9 here. All right, so the position of an object moving along a straight line is given by this, where it's t cubed plus 2. The position of a second object moving along the same line is given by t squared. If both objects begin at t equals 0, at what time is the distance between them minimum? All right, so the distance between them, I mean, if you just sort of graph this, like t squared goes like that, and t cubed plus 2 kind of looks like that. Um, and I don't know, maybe they cross or something. But how do you calculate the distance between them at any point?
Like what's it called? Like y2 minus wait, the distance between the 2 points?
The two curves, basically.
Yeah, top minus bottom.
Yeah, so the top is going to be this t cubed plus 2 minus the bottom is t squared. So to minimize something or maximize, you take the derivative. What is the derivative here?
3t squared minus 2t.
Okay, and could you set that equal to 0 and solve for the critical points?
T equals 0 and 2/3.
Okay, so now both of those appear in the after space. So how do we decide which one it is? You want to generally draw a number line here. E prime, so there's 0, there's 2/3, and you want to get the signs right. You want to test points in the derivative. So maybe like, 1/3 and 1.
Um, 1/3. 1/3 would be negative, right?
It would be.
And then 1 would be positive.
So is that a minimum there?
Yeah.
There you go. There's your answer.
And then I think I have to go.
Okay. All right. Well, good job. Thank you so much for scheduling.